Oh, I just got an email. Bad Cops Live. That's kind of cool. Maybe I should watch. Hello? Who's there? Anyone still awake on I guess it's not Christmas anymore, huh? It's officially a Boxing Day stream. Hello, 8 a.m. for me. 8 a.m. is pretty early. Or is it late? I hope it's not late for you. Let's feel like our minds are in a blender. Compiler session. Yeah. I've never, so full disclosure, I've never written a compiler. I don't know the first thing about writing compilers. So I'm gonna write a compiler. Because like, how hard can it be? I think the compiler people are just probably gatekeeping a little bit. It's probably really easy and they just don't want us to know how easy it is. So I feel like this is gonna take maybe 20, 30 minutes. Maybe 40. Should be pretty easy. It's hard and it's gatekeeping. Both can be true. Well, we're gonna cheat a little bit. Spoiler alert. We're gonna fork an existing compiler because I ain't doing all that. I've written a parser before, and that's not like the most interesting thing in the world. So we're gonna use one that exists, and then also let's ChatGPT that stuff. Nah. I asked ChatGPT for some hints here for some ideas of where to start. But I think what we're largely going to be doing is just forking tinycc. What's going on in here? I did a little bit of research before this stream. Cool. We're back in the starting state here. Let's see. Where do I want to put this? Do I want to just clone it into here? How big is this repo? There's quite a few files, but I think we're gonna clone an older version before it got so big. Hello. Yeah. Yeah. So how do we... Where do I want to stick all this? I mean, we could just put it in here. Submodule. Situation. How do I make it a submodule? Get submodule. Submodule add. Get submodule add thing. There you go. Here we go. Is that gonna ruin the stats on my... No, because the submodule wouldn't mess with my language breakdown. Cool. Yeah, it's just a link out to their repo. I probably should have made it my own fork instead of that, but that's okay. Fix that later. So how do we, first of all, what is the version of this thing that I actually wanted? This one. You can check out this. Cool. Make? No. Please run configure. All right, we got one of those. Make. Oh. Couple warnings. Never heard anybody. Oh. I think this is okay though. This is just like the documentation stuff. We can rip that out real quick. What is it? Texy to HTML. I'll be honest, I don't care about any of that. What was the other thing that failed? Make info. No rule to make tcc doc.html. Uh-huh. Oh man. Hello, 15 streams. Wow. That's crazy. That's a lot. That is many. I don't care about any of this stuff. Okay, we don't need to make tar. A 1 stream streak, that is also very impressive. I like, why is all this shit in the make file? I don't care. What lang are we making? We are making a C compiler because that's the easy one. On Windows, how do I get rid of that? I don't want Windows. A compiler that goes to bash. You're not completely wrong. Hear me out, because I had this thought earlier. So, okay, the idea, I haven't fully explained, but the idea is C compiler that targets the Synacor challenge VM. Because then we can like make our own little game that targets Synacor virtual machine, and we don't have to write it in assembly. However, since we have an implementation of the VM in bash, technically what this means is that we will have a C to bash compiler. Technically. Does the VM do syscalls? It does not. It does not. It does exactly 22 things. No, it won't compile to bash code, but it'll compile to how will calls to malloc work. Malloc probably won't work. I don't know, because we have, it could work. We could make a very simple allocator. But more than likely we won't need malloc. So like it's fine. Right now I'm just trying to clean up this kind of crazy makefile. Okay. Nothing to be done. That's good though, right? Make clean. Make. That looks good. Where did it output to? Oh, just right here. TCC. Okay. I was imagining if the VM supported just calling C, you'd just compile the C calls to whatever the VM does. No. It's a little bit more like, okay. So the VM does these things. It can stop running. Very good. It can set a register. It can push onto the stack. It can pop from the stack. It can check if two things are equal or greater than. It can jump, or jump this way or jump that way. We got 3 different kinds of jump. We got your add, multiply. We got, your math stuff, your save and load, call semantics, out for writing characters and in for reading characters, and then your classic noob. Call can technically call C. No, all call does is what it says right here. It writes the address of the next instruction to the stack, and then does a jump. You don't really need this. It could be just 2 instructions. It could be push and jump. I don't know anything about compilers or VMs. Gotcha. This is like a very simplified model of like the same thing that x86 does, or ARM. Wait, so my understanding is that C or bash or assembly goes to 0s and 1s needed by the CPU, right? Yeah, so normally when you compile a program, you run it through, like, let's say you have a C program. You compile it with something like GCC, which will it turns it into the 1s and 0s, but in the middle, it's turning it into, like, the 1s and 0s are basically the same as assembly. Assembly is just like a more human readable version of the 1s and the 0s. They're describing the same like steps. I imagine syscalls are possible. No. So, okay, this VM is entirely self-contained. Like it's a virtual computer that runs entirely within your program. So like I have a bash script that runs this VM. If that makes sense. So it can't do anything other, like it can't do anything really, except the only interactions it has with your outer system are these 2, which is the in and the out for writing a character to the screen or reading a character in. Am I technically a VTuber? No, I'm just lazy and I don't want the lights on right now. But yeah. So anyways, all we need to do is take an existing compiler and say, instead of spitting out ARM or x86 or whatever, I need you to spit out Synacor instructions. I kind of hate that it's called Synacor because that is just the name of the company. Wish we had a better name for this thing. It's my one complaint. That is the plan. We're gonna take TinyCC, which is a C compiler, and we're gonna follow some instructions that ChatGPT gave me. Maybe we're gonna try that. Incoming YouTube video? No, probably not. I don't know. I'm too lazy. I don't have any editing software installed right now either. If I did, then maybe. I gotta install DaVinci, is that the one? Or maybe Caden Live again. And get back on that. Because I was using Premiere and I don't have Premiere anymore. Because Linux. Hello, Elemental Magic's card game. How are you? Who needs to edit? And you're perfect in the first take. I'm not, though. I take so long to say things. I have to cut out at least the dead air. Me, when I'm trying to program, is like, so then what we'll do is take the number in register 0 and it's like so bad for video. You only ever need FFmpeg. While it's true, I am not very skilled with FFmpeg. I don't know what Idris 1 is, let alone Idris 2. It's time for C 3000. How many times have people implemented C? Okay, look at this. Look at this. I have a compiler. TCC. What does it do? Compile only. Makes an object file. Is this... What do you mean strikes again? Do we know this guy somehow? Who is... Oh, did he? Oh, yeah. Dang. That would explain why TinyCC is so popular then. Well, we're gonna steal his work. Not his original work. His original work on this was, I was looking through it. It's quite short, but it's also a little bit tangled. I think we're probably going to want a version more recent. Right. So how do you tell this thing what we're targeting? Okay, what if I just run this? I've got So if I do tinYcc, I deleted my hello.c. It's segfaults because that file doesn't exist. That makes sense. Hello world. Oh, it's still segfaults. Dash O hello. Oh, this is a rough start, I will admit. Aha. Nah. How do you do this? Is it dash dash args or something? Recompiling C. Well, I was trying. Wait. What is... Okay. How do you, how do you do args? Dash dash args. Oh. Oh. Dash dash args comes first. That's such a strange... Run? Okay. Segfault. Load object file. What are we loading an object file for? Uh-huh. What? It's loading CRT 1.0? What is that? See runtime? Why is it, why is it busted? You think? Yeah, I'm just looking to see if it's doing any optimization or anything. Don't think so. If def strip binaries. All right. Wait, why does it have CBP flags? Wait, did it compile? Hold on, what is it actually compiling with? Okay, it's compiling with GCC. Wait, is it? Hold on. No, okay. Yeah, it has -G and O2. Where's it getting O2 from? I didn't see that in there. O2. Just appears. Fascinating. Using Clang. For what? Just to compile this thing? Oh, no, I did look into that. That will be significantly more work. Can you give us some context? This is not for Advent of Code. This is just so there's this thing called the Synacor Challenge from 2012, where you make a virtual machine. And we just finished this the other day. But now what I would like to do is make a compiler that compiles to this virtual machine. But it's busted. It sure is busted. Can I? I mean, deconfig multi-arch dir. What if I run it from this folder? Just as a, or what if I run an example actually? Maybe I can't no, even that. Trying to use TinyCC. Yes. But but TinyCC out of the box is just segfaulting, which is interesting. It's segfaulting trying to load CRT. Have I considered LLVM? LLVM looked significantly more work from my minor research. Where is this happening? libtcc. Why aren't you using the upstream version? What do you mean by the upstream version? Like the latest? It looks significantly more complicated in the latest. Yeah, I was using an older one because it looks simpler. This thing has gotten less and less tiny as the years have gone on. Like, I'd almost rather go back even farther. I feel like I'm too obnoxious to be in this chat. No, you're good. Maybe we should get this one. I mean, we can try main, but I have a feeling, let's see. Make clean, GCO. Stash. Make. Oh. Well, now it's just broken. Make dist clean. Make. Oh, I have to rerun configure. There we go. Nora? What's Nora? Oh, Happy Nora is here. Your name is the same length and color as Tired Beavers, and I just pattern matched and I didn't even realize. I apologize. I was like, what are you talking about? Include file tcclib.h not found. Dash I include. Yes, where is tcclib? lslib. What? Oh, wait, no, it's right here. What? Include standard def not found. Okay. Oh my god. It wants so many things. How do you make these examples? It's just the goalposts keep shifting. Library lib not found. Oh. Wait, what? Does the makefile have examples? No. More complicated example. Might be part of the all target. Nothing to be done. Yeah, there is a shebang, but I wanna compile it. I don't wanna run it. I mean, maybe when you run it, it does compile it somewhere. I'm not sure. Oh, it tries to use user local bin tcc. Okay. Yeah. Yeah, okay. Include file not found. It's literally right here. Maybe I have to put this beforehand. Okay. It needs so many things. What's the error you get from a plain make? There is no error. So the compiler itself builds. It's just that it doesn't what's in the root dir? Oh, yeah, I mean I got it to find that, but it's just like endless with all the things that it wants. Now it wants some libs. It wants libtcc1.a. Was I supposed to do like make install? Okay, maybe I was supposed to do make install. That could have been the issue. It like expects things to be in the right place. Examples ex1. There we go. Hello world. Okay. What we got in here? Okay, so you use tcclib instead of standard IO. That makes sense. They have their own printf implementation. Okay, this is good. This is a good thing that has happened. Now, how do we tell it what arch we want to run or compile to? M3264. Hold on, I think ChatGPT knew something about this. Dash target? I don't think that's a thing. I think you made that up. I think you're lying. Let's look at tcc.c target. Okay, these are target specific options. So it uses this. There's like a tcc target thing. Yeah, look at this. Do I just do like a -d? Like I want oops. Maybe not run. Where did that make it go to? A dot out. How do I look at this thing? This is an elf. Would arm still be an elf? Probably. But it sure as hell wouldn't run. So I don't think that's actually arm. Can we find this? Somewhere in here. ARM64 elves are a thing. Yeah, but it wouldn't run on my computer, right? We can target C67. Maybe it says it has similar flags to GCC. So maybe, how do you do this in GCC? GCC change target arch. M arch. Sure. Why are you always lying? Wouldn't you need the object files to also be in that architecture? If you're going to be cross-compiling, I'm not cross-compiling. I just want to figure out how to make it hit the code path for, right? I'm only going to compile to one thing, but I'm just trying to figure out how to make it even switch what thing it's compiling. Yeah, okay. Back into here. What do we have? We say arch anywhere? Ignored options, arch. Curious. How does it choose? Okay, wait. These are set at compile time, right? Of the TCC, not of our program. So it's already compiled to work with x86. I see. Just trying to compile a single file. Yes. Probably. Okay. Well, we could just gut the x86 one. This one? What's this one? Oh my. What? Okay, it doesn't know where that comes from. Also be a safer bet. LLVM is gonna be like, that's not gonna be a hacky little project. That's gonna be like, yeah, I don't, that's too big. What is going on in this file? What does def asm op do? Oh, it's for the, wait, what? Okay, hold on. I mean, with LLVM, you can implement a backend. It's just that the like LLVM IR is much bigger much taller of an order than some of these smaller ones. Like TCC has more or less stuff that we need to implement. As a result, like the output is shittier, but I don't care about that. I did see crane lift, but I didn't look into that one really. Yeah, comprehensive is not what I'm looking for. I'm looking for minimal and simple. What are we compiling? Nothing so far, but I want to be able to write a little game for this VM in C. Is the idea. I don't really understand what is going on in this file. Yeah, making brainfuck go to the VM would be very easy, but is less useful because then we have to write brainfuck, and it would be easier to write the assembly language for the VM than brainfuck. Somebody has a C to brainfuck? Yeah. But the level of gross that is, like the output is gonna be just so nasty. Are you doing the backend for a custom VM? That's the idea. Yeah, I think going through brainfuck, like, just, it's gonna be really slow. No, it's not though, because like, think about it like this, right? You're running it through. What's an example here? Just use a random C parser. Yeah, it doesn't require register allocation. I was looking at doing that. ChatGPT tried to convince me that TinyCC was going to be simpler than the other one that I was looking at, which was ChibiCC. Because this one, I think all we would need to do is the code gen file. But this one is kind of written around x86 specifically. So it might not be the easiest conversion. What's the VM like? It looks like this. But I do think this is somewhat doable. I don't know. I'd have to understand what a lot of these are saying. Is this Synacor extended? Yes. This is Synacor after hours. I don't know. I still think TinyCC could be the way. I just need to grasp what it's x86 what it's doing here. What operations does it have? If you look at the link that I sent, it has the breakdown of all the operations. Mm-hmm. We're trying to build a compiler to run arbitrary programs in the Synacor VM. You know it. I want to write C and have it run in my Synacor VM. I'm not sure how tall of an ask it is, but we're gonna try it. Why is there so much stuff in this file? Like, I actually don't. I think ChatGPT is gaslighting me. Yeah. What about the i3861 one? Wait, there's a ASM and a Gen and some other stuff. I think this is the one it was originally written for. This one's a lot smaller. I can open the ARM one. ARM Gen. Okay, this one's 2,400 lines. This one's only 1,100. Ooh, redo. Okay, make TCC new. We do some args stuff. Set the output type. Oh, yeah, obj or exe. Where does it actually run? TCC run. No, that is, oh, output memory. That's how it does it. Yeah. Otherwise, TCC output file? Or is it TCC add file that does the interesting things? Add file. Hmm. Ah, TCC compile. Here we go. Compile the file opened in file. Return non-zero if errors. PCC. I haven't heard of that one. I did look at Chibi though. What's the deal with this one? What? Oh, this one is just like all one file. The idea is to probably fork one, yeah. Because I don't need to rewrite the parser and everything. $2K is nothing. TCC. Maybe I should just step through this thing. What do you think? Here we go. How do I break main? Run. Here we go. Okay. What? What's happening? Did we already crash? No. It just can't find these files. Okay. Why can't it find these files? Where did I run this from? Shouldn't it just be in standard lib? No. Where? Yeah, I do wonder if this one is like has just grown so big. Like, what is lib arm64? Runtime library for arm64. Like, am I gonna have to write a runtime library? It's like a lot of floating point math and stuff. I just want to use floats. Easy. Yeah. Well, do I though? Or do I just not need to... Do I need to just not use those functions? Hmm. What goes on in here? I mean, we can definitely implement things as needed. What is going on here? Okay. Ah. Okay, yeah, there's some... What is this one? I386 specific functions for TCC assembler. Mm-hmm. Yeah, I don't know what's going on in here. What did the ChatGPT say we should be doing? It hallucinated this target thing. Good start. Good start. Wired into the target switch. But there's no switch in there. It's just a lie. So that's cool. Ah. You really want to generate binaries or just want to figure out the result of running it? What do you mean? I mean, yeah, I want to generate a binary. That's what a compiler does. You could make the VM itself compile it. What? God, this is how you tell it what you want it to the emit. Take your already working VM and make each instruction also write x86 assembly. That is not what I want. I want to make the VM assembly from C. What is going on? Are we still trying to go from C to VM? Did you think it was going to take 1 hour? What do you mean? Are we still trying? Like, what? I'm sorry. Should I be done? Oh. All right. Let's make our own. Write the compiler in handwritten Synacor assembly. So true. Oh good, this just all got formatted. I mean, you are welcome to do that. That's not what I want to do. Going through brainfuck is like, I was trying to think of an analogy. It's like if you had a fire hydrant, right? And you want to connect it to the fire hose so you can spray some water, but in the middle you have a funnel. You have a funnel that's just like half a centimeter in diameter, and you're wondering, why is the water coming out of the end so slow? And then you're like, oh right, the funnel. That makes sense. Because you're going from C to 8 instruction language back to a 22 instruction language, and like you might as well just write a brainfuck VM at that point. Like, what's the point of going back to the bigger VM? You've already lost the plot at that point. Like, it's just a brainfuck program. What's happened so far? Just planning? Yeah. Pretty much. And this, a little bit of this. Configure. This should not build, I hope. Did it build? Sure built. I mean, it would probably work. It's just like the resulting thing is gonna be so dog shit. Like, you go from having a language where you can add two numbers to having a language where you can increment a number, right? Like, you see how that's gonna like explode computationally. Oh, you want to print a string? That's 10 billion operations. Like, I don't know. It's just kind of awful. So why did this still build if none of the things were defined? Was one of the things defined? How did it get a thing? How did it decide? Okay, it looks like it actually made all of the objects, but then wait, is it actually compiling itself? Whoa. Is that what's happening? You seeing this? Kinda cool. I don't really understand where it's deciding. Yeah, that's I feel like I'm just gonna be a broken record all stream today. That is something I investigated and decided would be probably more work than it's worth. LLVM is like the enterprise edition of this thing. It's the like we would have to do a lot of work to get it to even start to compile stuff, I think. Only native compiler supports -run. Sure. You can just read each short from the file in a loop and emit the code you want. I think you're thinking I want to go the decompiler way. I want to go the compiler way. uh, do 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 do. Huh. Bash ++ compiler? No. This is for the Synacor thing. I want to go C to Synacor VM. I'm not sure this version of TCC might be too sophisticated. Like it's just got so much stuff. The older versions have a lot less stuff. Legitimately, this thing is not tiny anymore. It's betrayed its own name. Like this looks tiny. Large CC. Yes. That's fine. Default target is I386. In fact, it's the only one. Oh, there was a lot more code in the main thing back in the day. The end. Are you doing the compiler in Bash? No. No. So far, we're not doing it in anything. I don't know. I just don't know. How much trouble is it really to implement backend for LLVM? It doesn't look nice. It like there's like a lot of stuff. There's like a lot of stuff. There's like a lot of things. Yeah. Like, I think if that was the level that I needed to do it at, I wouldn't. This would be a non-starter essentially. So that's ruled out by default because I don't want to do it. So that makes that one easy. Wait, what is this table? This table is for typecasts. Oh. I feel like maybe I should just use Chibi. Like, I'm also a bit worried if without DMA and SSE, how much performance you can get. I mean, it's going to be like a text adventure game. It doesn't need to be, it's not going to be drawing frames. Hey, Sesh. Text on 120 FPS. I think Bash is going to become our bottleneck before the, before anything else. Our VM is suddenly going to be the issue. It already kind of chugs when you render text. Hmm. I don't know. Should we go back and argue with ChatGPT some more? Maybe. It recommended. It was pretty adamant that we should do TCC. Implement a dumb emitter. What not to do. I don't. It doesn't inspire confidence that it thinks TCC has a target switch. Like, do these even exist? Okay, this exists. What is this thing? Generate function call. Function address is pushed first, then all the parameters in call order. This function pops all the parameters in the function address. This functions pops. Is there a way? No, it's definitely gonna be C. I'm not gonna write the compiler in Bash. I don't see any reason to. Uh the Am I actually doing it? Targeting Synacor? I'm trying. I am trying. We're investigating the situation. We're doing some research. Is there a nice way that I could just like strip out everything that's like a hashtag define that doesn't apply to me? I would love to just clean up this code and remove all of the things for platforms that don't apply to me. But I guess it's fine. I can do it by hand. Are you considering adding opcodes or just simulating stuff you need? What do you mean by that? Adding opcodes? Oh, like to the VM? No, it should compile to the existing VM. All right. So when we compile this thing, where does it actually build? Here. But it's doing x86 gen and link and i386 assemble. Is this part of the make file? Seems to be a decent amount of documentation on TCC's code generator. Do you have a link? I may have already seen it, but oh, there's a make help. Interesting. Oh, make cross target. Build one specific cross compiler for target. Oh, neat. Code generation. Let's see this. This right here. Directly generates. Oh, I have not seen this yet. Okay. Right. Jack the educational language. I'm not familiar with that one. But you should get it running in the browser, and then we can make C programs that can run in the browser. Oh, from NAND to Tetris. When an expression is parsed, its value is pushed on the value stack. CPU dependent code generation. See the i386 gen C file to have an example. Load must generate the code needed to load a stack value into the register. Okay, yeah, this is what we want to implement. Yeah. This should be all we need to get started. Cool. Okay. Make help. Make cross targets. So I think this is what we want to. This is the exact thing I missed doing on my thesis years ago. We want to somehow get ourselves in this list. So this list is coming from TCCX, which is this. What do we... Okay, sure. Synacor. Boom, I did it. I'm so good. Crosslib TCC 1.a targets to build. Put some spaces there. Assume support files for cross targets in user triplet by default. Yeah. So what is up with that? We don't have support files. Uh, I need a Duralic x86. But what goes in that file? Oops. Yeah, yeah, like what is okay. That doesn't exist. Or user lib. Oh. That's where all these things are. It's fine. It'll be fine. Just don't think about it. Just keep moving. It's fine. Um uh let's go lowercase. Okay, so what is x86 doing? It's I don't know. Can we just make our own called Synacor? Well, we're gonna need the tokenizer, no? I assume that's what this is. Why is the tokenizer different depending? I don't know. I don't know. Yeah, I'm just hoping I don't have to write all those files. We're gonna start with that and see what happens. All right. So it should just be make cross Synacor now. Okay. No ruled make target synacorgen.c. Probably because this file does not exist yet. Okay. It builds. Oh, redefined? Really? Oh. Yeah. This is not necessary. Cool. So yeah, whatever. Nah. Nah. I'll just delete the license for this file. Copy the x86 one. This is I think this is gonna be the simplest one, but also I think we're gonna just like delete everything in here. Pretty names for the registers. R0, R1. There we go. Those are pretty names. I don't know. I'd rather start with less code than more. I don't know what this is talking about. NB regs and then NB ASM regs. This does not look like bash. It is not currently bash. This is C. Sorry for the debate. Target defs only. What is this else in response to? If def target defs only. If def target defs only. If we reserved 4K words, that's enough for a 256 display. Yeah, I guess the pointer size would be 2. That's a good. The long double size. Like, what is any of this for? Does it get used anywhere? Outside of this file? Make it faster? All right. Let's hear me out. It's gone. Function parameters must be evaluated in reverse order. Why would that be a thing? I mean, we don't have anything. I don't know. Let's just leave this stuff alone for now. So this should not work because I deleted all the code. Huh. Well, now why does that Does the Maybe I don't understand what the... No, okay. How is it still working? I deleted all the code. What? Well, it didn't take Synacor TCC as a source for whatever reason. I'm very confused. Like it can't make something. Yeah, okay, there's no lib. I see. So it makes a library. Oh, okay, I see. Huh. So how do I make this thing? I would have thought that would have made it. Synacor libtc 1 1. Didn't it regenerate? I don't think it made it, right? Oh. It tried to, but like I don't think there's any way that this worked. Okay, that works. What? It is right there. What's in it? This is why I didn't get into LLM development. Do you mean LLVM? Compilers are LLMs. That is your joke. I'm not sure I get it. Why not become a good cop with a borrow checker? Why? Let's ask good cop. Do you like the borrow checker? Nope. Okay, never mind. It should contain the code generator. Yeah, that's... But like, didn't I delete the code? Yeah, okay. Our library has 8 bytes. What's in it? Arch. That's a good. That's a good A file. What kind of compiler are you writing? I would like to write a C compiler. Well, more correctly, fork an existing one. Huh. I guess I'm a little bit confused by how it's trying to build this thing. Because it's making this .a file, but it made it using itself. Right? So use GCC to compile tcc.o. And then it archived the fucking nothing. Can we look at what it does when I make cross I386? Oh, there's this thing, TCC cross prefix. But yeah, it takes in, oh yeah. It makes more stuff. It compiles things. But it's using itself. Writing C compiler in C using GCC. I'm trying to use one called TCC. Why does it make with itself? So how is that ever gonna work? Am I inventing a language? No. I'm just gluing some stuff together. It's 4 a.m.? No, it's 2 a.m. So it we make this O file. And then oh. Okay, I don't think we want to do the make cross thing. Wait, do we? Oh. I think I get what's happening. Wow. Because, oh, so it needs to compile all of these things. It's not an O file. Well, this one makes an O file. And then this one makes a binary using the O file. And then this thing is used to compile all of the libraries, which makes sense. Because this is how you get stuff like malloc and whatnot, is by building the allocator to your specific architecture. So this actually does make sense. I think our thing is busted. Why would you need malloc? Well, I mean, I don't in this case, but Like that's something it can do. Like right now I'm just looking at what it's doing for i386. So it's cross-compiling all of these things to that, and then linking that. Wait, what is it? What is the final artifact here? I guess it's just all of these object files that we or no, oh, okay, yeah. It emits a library from all of this using AR. Advent of code task was to write a compiler. No, I'm not doing advent of code. That has been finished for a while. Do I still have like a tag or something? Is it because of the folder, isn't it? I see. I'm wondering why people keep asking that. But okay, so what did ours do? Our guy ran, and it didn't put anything into the final library, which makes sense. Our standard library for our are you doing the senator thing? Synacor? But yes. But also we're already done, and we're going the extra mile. We're doing our victory lap. So this makes a lot of sense, I think. I'm just surprised that it compiles at all. Like, I'm surprised we're allowed to compile the nothing compiler that has no functionality. But okay, am I allowed to use the i386 TC hello hello b dot dot I dot dot oh no, because mine. Okay, let's go from the examples instead of hello. Examples ex1. TCC lib not found. Well, that's, where's that? Wait, no, that's right here. What? Do I have the flags in the wrong order? No, they're doing it like this, aren't they? Huh. Why don't we have... Why don't we have TCC lib? .h. Now I'm confused again. I've been here for 5 minutes and it just looks like a web of confusion. Welcome to the stream. That's what we do here. We do confusion. Byte saved. You know what? Yeah, you're right. Let's just let's just enjoy the snow, you know? It's the night after Christmas. We earned a little bit of snow. No more web of confusion. Just bury it. We don't have to look at it anymore. Just give it a few minutes. Yeah, just hold on. Let it cook. I thought my pixels started to die. I'll be honest. I don't know why we can't find the file that's like definitely in this folder right now. Increase the loop speed. I could. But that wouldn't be very realistic. How fast do you think snow is? How fast can snow go? What's like the terminal velocity of snow? I think it's just whatever the wind speed is. Yeah. But that's cheating, right? Like, how fast would snow fall in a vacuum? I mean, it's already pretty good. I already can't see what we were typing anymore. Same speed a dumbbell hits the floor? Wait, that's true. Because there wouldn't be the air resistance either. Would it even continue to be snow in a vacuum? That's the important question. That's the real question we should be asking. All right. Why can't you find this? Like, are you sure? Are we sure that you can't find that? Cuz I feel like it's right here. It is right here. Do you know how to do this? Do you know how to write a little compiler guy? Or rather, get this current one to compile? I don't know how. I'm trying. I don't know what I'm doing. Dash I dot. I have I dot. Oh wait, I have I dot dot. Oh, I'm a fool. I am the fool. Okay, it works. Yeah, you got me. I did I dot dot because that's what they had in the make file, but it's not right because we're not in a full. Yeah, it's fine. We get there. Okay, it works. What's in here? What is this? It's a little elf. Nice. I don't think I can run it. Where did I write it to? I wrote it to hello. I don't think this is gonna run though. Yeah. Exec format error. That makes sense. It doesn't, it's not for my computer. But that's good. That's what we wanted to do, is exec format error. It's an elf, but not a Christmas one. Yeah. Cool. Most I've wrote is a neural network in C. I've never messed with neural networks. What am I doing? Okay. Since you know about compilers, I will give you the spiel. So this is what we were doing the other day, is this Synacor challenge thing. I think we talked about it a little bit. Basically, what you're given is a specification for a virtual computer. This computer has 22 instructions. And it's like it's a stack computer thing, you know? You got an unbounded stack that holds values, and all these things. And I would like to make a compiler that can make a program that runs on this system. That's my plan. That's my goal. I don't care if it's really bad. I just want it to be able to like if I can get Hello World in C to run on this VM, I'm going to be very excited. What language do you want? Probably C is the plan. Seems like the most, I don't know. Probably the easiest. You have a better option? Okay, I'm curious. I looked at some other ones. TCC seems like what I want, but it also seems like it's gotten bigger over the years that it's existed. Maybe not so tiny CC would be the good name for it now. Author of Moss. Oh. So admittedly, I had a little bit of a conversation with ChatGPT before this stream to suss out what good options would be for this. And ChatGPT convinced me that TinyCC is probably the right one. If you want to go crazy, a simple Lisp would be cool too. The problem is I suck at writing Lisp, so like it doesn't really make my life simpler. It just makes my life complicated in a different way. Like I'd almost rather just make a nice assembler and then use that directly. TCC is too complex. You might be right, but it might also not be. I don't know. Where was the thing? This thing. Like, it says all we need is load, store, these ones, this one, floating point operations. We'll just ignore that. It's not Moss, it's Mold. GitHub mold compiler. A modern linker? Wait, this is the same avatar as the ChibCC one. Are you thinking of ChibCC? Yeah. Okay, so I looked at this one, and I was also convinced that this was right. But you know who wasn't? ChatGPT. Where did we talk about this? I said, what about ChibCC? Yeah, I mean, but I'm also like completely out of my depth here, so that's why I was like just throwing stuff at the wall. But I don't know if this is right. Like I have no idea. But what it's telling me is that TinyCC does some things. Yeah, like TinyCC already thinks in stack machine terms, whereas ChibCC thinks in like specifically x86. And so like I would have to rewrite the whole code gen thing, whereas with TCC I might have to do less. Is the claim. Did you do fact check though? I don't really know how to fact check that. Like I read both of the codes. Chibi did seem well, that's the thing. I don't think we need to do register allocation. Like I think we can just do the dumb thing. Do you trust a random chatter? I mean, it's not a random chatter. I trust this particular chatter. With TCC, you'll have to learn a complex code base. Yeah. This document that we found does inspire a little bit of confidence. I think if I can't get anything to work here, I will maybe go to Chibi. But TCC, I vaguely get what's going on here. Now I didn't until 2 hours in, but if we look at, so here, I can walk you through what I know so far. In the make file for TCC, you can specify that you want to compile a cross compiler. The words get so confusing here because the word compile is like overloaded as fuck. But we're making a version of TCC that compiles to i386. Is what this make target does. And so we can look at what it did when it ran. We can see it started out by making this object file using just tcc.c. So it's making like a wrapper program that runs on our host with GCC. This is like the front end of the compiler. This is like the main function and the args parsing and everything. And then it also makes it just makes a binary out of that. But this thing itself, like, well, fuck, hold on. No. It must be doing something more than that. Do more source files get added in here somewhere? I don't 100% understand what's happening here. Maybe that just gets included through here. But I thought there were other C files. Anyways, moving on. After that, yeah, it does some bootstrappy things, and it uses the thing that it just made to like compile this is the part where it makes the library file. If it's included, yeah, that's what I'm wondering. If we go to tcc.c, if one source, it might be, maybe it's doing this one source thing. 3.8. Oh yeah, look. You said you always do things the wrong way. Does it apply only to bash scripts or just programming in general? Most of the things I do on stream are... What? You talking about this? Yeah. Yeah, it does some things. Presumably it's including, like it has to be, because it's making a compiler that runs on our host. But then it uses that compiler that it just made to compile a bunch of like libc type things. I guess. And then it shoves it all into a .a file. Although I don't know what I'm gonna do with the .a file because I don't have dynamic linking on the VM. So we're gonna have to figure that part out. We might have to write our own printf. But that's okay. Like, I actually don't mind if we have to write our own everything. This would be cross-compiled to run the compiler on your VM. No, I don't think so. This compiler runs on my host. Like, I can run this right now. But the things that this compiler spit out run on the VM. Like, we just made a hello world that is an i386 binary. So like if I run it, it's just like, what the fuck is that? Which I think is good. I think that's what we want to happen. So I think we need to do the same thing, except we're making the our own version of this now. So like we want to make cross Synacor And then surprisingly that does work. But then this one like just sucks, I think. Like it still has that, but if I say make this. Oh wait, what? What? No, not yay. Why? What is this? What? No, that's not supposed to be a thing. Why did that make an x86 binary? If you go the full custom route, you'll need a tiny Lexer parser. Yeah. Yeah, I don't want to go that deep. I don't want this to be like a long-term project. I want this to just be hack it together. Didn't you copy? Yeah, but I deleted all the code is what I'm confused. Like, look. Like, I deleted everything that was in this file. tcc.c. Is there a way to print out all of the files that are being included? Just as like a debug info? Like anything that's being hashtag included? GCC print includes -h. Yeah. Cool. Okay, it is using... There's a lot of stuff. Yeah, it's pulling out a lot of these things. But that makes sense for... Well... But does it? What's in config.h? Oh. Don't we want our... Probably need that in here. Oh, there we go. That looks better, maybe. Doesn't compile. That's more like what I would expect. Great. I think. Yeah. Maybe. I feel like we're missing something though. Because automatically generated by configure. Maybe I shouldn't have modified that. Make dist clean. Configure. Huh. Where? Where does it make it? Yeah, it seems like a neat compiler. Ah, here. Why don't we have pointer size though? That's what's confusing me. Because I'm pretty sure we left that in there. Yeah, what a name. If def target defs only. Oh, is it because this is busted? Maybe because that's busted? No? Why is it not including this file anywhere? It's mad in tcc elf.c. Okay, so this includes tcc.h. Which includes config. We did this one. I don't know. Should we just look for like all of the... Maybe there's other places we need to add our stupid thing. They couldn't just make this like a global define somewhere. Where does it even TCC gin? All right, let's start at the top here. Unknown target. Ah, look at this. This is what we need. This is what I've been looking for. Yeah, I really don't want to make the linker. Maybe it's unavoidable though. All right, look how few errors we have now. All right, treg EAX undeclared. All right, new plan. Let's see. Can you explain WTF is going on in this part of the i386 gen.c? Oh, 2 responses. Wow. You knew this was gonna be a good one. This block is not code gen. Really? I had no idea. Oh, it's not code gen because it's doing a bunch of pound defines. Okay. Big picture. This block tells the front end how many registers exist. Yes. Right, because it's doing other stuff. Available for the compiler's allocator. If you don't want register allocation. Oh. Well, maybe I want to just start with that. That would be nice. Register classes. This is the confusing part. Yes. These are bit masks describing register capabilities. Give me a register that satisfies class X. Well, what if all my registers are... For your VM, you don't want this at all. Can you link to the VM spec? Yes. Define one return slot. And always store to memory. Does it trigger translation unit optimization? I have no idea. Pick a word size, probably 2 or 4 bytes. Oh shit, am I editing the wrong one? Yeah. Yup, classic. Number of registers, 1. Can we just say 2? Can we just make everything 2? Okay. In tccpp.c, we've got an error. You're gonna have to map some ABI registers into the 8 you've got to work with. I don't know what that means. But yes. You can delete this safely if you control everything. Sure. Only 4 codes so far, but just getting the VM working felt good. Yeah, it's nice. Is it not better to go AST to bytecode? Which registers are generic? I don't think we have to if we just set registers to 1, probably. Then it'll just like store and load every time. Like it's unnecessary, but what do I think about random link that I'm not gonna click? Don't know, never heard of it. Do I need this reg I return? Probably, right? Well, maybe not. What did we say about this one? ABI contract only. Well, if that's true, then can I just get rid of them? No. Can I just make them all 0? Okay. We're down to the good stuff. We don't have our data pointer. Don't know what that's supposed to be. Shall we go searching for this? Okay, this is in the linker stuff. The linker is not that big. Maybe we just copy the linker. Seems sensible, but working backwards from your goals to see what you want. Need seems like a better approach. My advice, if you want to learn programming, is always just going to be to program. It's not like as mystical and as arcane as it seems. You don't need like some certification to start doing it. You can just start doing it, and you'll be bad at it at first, and then you'll slowly get less bad. And that's it. Like, that's the whole thing. I don't know. No. You want to see the streets I grew up on? This is where I come from. Here you go. This is all you need. If you want to be like me, follow this quick tutorial. Real ones, no. I can't believe this site still exists. Actually crazy. Also, my ad blocker is just not working. Or are these not ads? This is just, they're advertising themselves on the thing. Don't buy whatever this is. You don't need this. Okay, maybe this isn't a good site anymore. Not so much about programming, but computer science topics. Yeah, for that, I mean, I still think you can just learn that stuff on the fly. I don't know. I did go to school for computer science, so I don't know what the best self-learning resource for that is. Instead of boot.dev, hashtag sponsored. I don't know. Did read a few books on the list. Yeah, I would like to know what's on the website, but I don't. Especially if you're a first-time chatter and you're gonna drop a link in chat, I'm just not brave enough to click it. I'm sorry. But yeah, I would, if you want to learn algorithms and things, I would buy a copy of the book. You know, get yourself like a PDF of it would also be fine. You don't need a hard copy, but get the book in some form. Read the book. Love the book, hate the book. Maybe cry on the book a little bit. And then have it sit on your shelf for the rest of the time. It's a rite of passage. Children have nightmares about the book. Did you find TCC's AST yet? I don't know if it has an AST per se. Yeah, mostly just sits on the shelf. Very rare that I reference this book anymore, but like I have read it. It's a good book to read. I don't know. I haven't really looked at that side of TCC yet. And then once you get this book down, you got to get the other book. You got to get the green book. Then you'll be ready. Then you'll be ready for the 2010 interview process. It's the only two books that exist about computer science. It's cooked though. Yeah. The interviewers have had too much time to crack the crack. Yeah. I don't even know if I could reverse the linked list, to be quite honest with you. I mean, I could figure it out, but I would be stumbling. It would not be a smooth smooth process. There would be a 10-minute debate on whether or not I wanted to use recursion or a loop, and then we'd be there. Oh, don't even start with your fold nonsense. What the hell is even that? Do they have fold in this language? PHP fold. Oh yeah, we got you can use hashtag region and then you get code folding. That's what you're talking about, right? It's all code folding. Oh wait, case folding? TCC is a parseless compiler? Yeah. Single pass. I don't know what this means. Did you know PHP has traits? You in for pain with this one? No, 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 no. I actually think it's gonna be good. Anybody familiar with PHP's traits? These are good too. Yeah. They're not quite the same as Rust traits, let me tell you. Let me tell you, they're quite a bit different. No, this is not at all the same thing. No, it's so vastly different. Uh, uh, the way that I've seen this described in the comments below is that this is copy paste as a language feature. This is hello, please copy paste this block of code into my class right here. And this is the same thing. Please copy paste this block of code into my class. And then you have it. You have the functions because they've been copy pasted in. And then there's some like precedence rules for who gets copy pasted first. Oh, and you can make traits out of traits. You can make recursive copy pasting happen. You can make the hello world trait that uses the hello and the world trait. You can have abstract trait members. Haven't you always wanted abstract copy paste? Look at this. You can have your trait that's hello, and then it can public function say hello world, which is gonna hello, and then sorry, this dot means concatenate. Stay with me now. And then we got an abstract public function get world, which obviously does nothing. But then here, when we use hello, you know, we have to implement the get world function. Otherwise, where does it run? Oh, wait, what? The output is nothing? Is it broken? Oh, wait, this doesn't... What? This doesn't actually do the thing. This example sucks. Okay. So if we were to say like, oh, wait. Why is it a private? Oh, okay. Oh, set world, Mars. Yeah, look at that. There you go. But then what if we didn't, what happens if you use multiple traits with the same members? Yeah, that's what the above stuff is. There's like rules. I don't know how it works. But what if we delete this? Do we get an error? Yeah, we get an error. Fatal. Contains one abstract method and must therefore be declared abstract or implement the remaining method. There you go. It's like interfaces, kind of, but worse. Let's see. How does the precedence work? Conflict resolution. If two traits insert a method with the same name, a fatal error is produced, unless you explicitly resolve it. Yes, using the instead of operator, or keyword. You're going to want to use the B small talk instead of A. Java style, yeah. What's the precedence thing, though? An inherited member from a base class is overwritten by a member inserted by a trait. Okay. Yeah, so if you have some function that you've inherited, you can also override it with your trait. This one's not a fatal error, because why would you want it to be consistent? What you really want is sometimes it should be a fatal error and sometimes it should just work. Static trait members. Hold on. Oh, good. Oh, good. How do I say your name? Is it Sokem? Sokum? One of those? But I think TCC... Why do you think TCC is not going to work? I think the emit text is going to be... Yeah, I mean, I felt the same way, but like, I think basically the entire code gen file of Chibi would need to be replaced. Did you ever look at hack? No, not in a long time. I don't know. Yeah, here. The best way to understand what traits are and how to use them is to look at them for what they essentially are. Language-assisted copy-paste. If you can copy paste the code from one class to another, then you have a candidate for a trait. Oh. Language assisted copy paste. Good stuff. I don't know, call it sunken cost. But I think Tiny CC is gonna be more inclined to do the thing that I want. I'm scared. Yeah, I get that, but is it? All right, let me take another look at it. Codegen.c. The problem with Chibi is that I'm gonna end up having to replace a lot of x86, and I don't know. Yeah, but TCC turns it into a little bit more of a whatchamacallit. Like, it is doing some transformation on the code. Like, I think the way to think about it is like TCC is doing like 3 steps, and Chibi's doing 2. And in TCC we can use the first 2 steps and replace the third one. Or in Chibi, we can use the first step and replace the second one. So it's like, do we want to rewrite 50% of the program or 33%? It's not the exact math, but that's sort of how it plays out. Like, this is missing that middle step of converting it to like I'm not sure it works that way. It does, I'm pretty sure. Where's that page? This page. Okay, this is how to use it. This is what language features it supports. Linking developer's guide. TCC assembler. No, TCC has code gen as well. The TCC code generator directly generates linked binary code in one pass. It's rather unusual these days, but it can be very fast and surprisingly little complicated. The TCC code generator is register based. Optimization is only done at the expression level. No intermediate representation of expression is kept except the current value stored in the value stack. When an expression is parsed, its value is pushed on the value stack. svalue.r indicates how the value is currently stored in the generated code. It's usually a CPU register index, but additional values and flags are defined. But yeah, I'm pretty sure these are the only things you need to implement is load, store, gfunc. I'm not sure what a prologue and an epilogue is. Must generate the binary integer operation op on the two top entries of the stack, which are guaranteed to contain integer types. Result value should be put on the stack. So I just think this one is a little more abstracted than Chibi. Whereas Chibi is just like, I don't know, walking the AST and then expecting you to emit a bunch of stuff. Yeah, they do. This one is a little more designed. But that does make it more confusing, I won't lie. But I think it's going to be overall less work. What is that question? You've been here before and you've sent the same thing. I don't understand you. You're a strange person, Jim the Dandy. That guy that dropped the random link never spoke up again. He might have left when I said I wasn't going to click the link. I don't know. Oops. Oh well. All right. I was going to copy this. I got sidetracked. Link. Synacor. We're going to have a linker, I guess. I don't know what it's going to do. One of these has the thing here. All right, we don't have gen OPL. So let's make that. Gen OPL. Is that not a function? Gen OPL? Oh. Interesting. This one has a different one. Gen OPI. What's I? Nope, here. Cool. Add with carry generation. Don't know what that means. All right, what does this O function do? Oh God. This function is crazy. How long is this function? It's a good function. I mean, can we just have it do nothing? Is that legal? To get it to compile? Whoops, wrong button. Okay, we don't have gen OPL still. Why does it want gen OPL instead of gen OPI? If pointer size equals 4. Uh-huh. But ours doesn't, right? Ours is 2. What's going on? If it's 4, they do it for you? I don't know, because like the i386 one only has gen OPI. What's the pointer size for that one? 4. But this is saying we're missing a gen OPL function, which we I don't think we need. We don't even have longs. It's got to be something in here. No, the pointer size 4 thing was around gen OPL. Or you're saying they're creating gen OPL for me? Okay, what is gen OPL? I guess I see what you mean. Where was it? What if we just delete this if? Lol. Don't worry about it. Lol. L expand, L build. Oh, we don't have any of these things. Just take the low order word. There's so many things in here that we don't actually care about because, like, expand 64-bit on stack in 2 ints. I mean, it's cool that they're doing all that, but I actually just don't care. I don't want to be able to use longs. I'm just gonna delete this again. Fuck it. All right, now we don't have G reloc. So what's that? Why do I feel like this is gonna be a linker one? No? G reloc. Oh no. More of this if pointer size equals 4. I'm simply not worried about it. Simply, it's fine. Deal with it when it comes up. All right. Gen LE32. Great. Finally one I can copy paste. What does G do? I've got no idea. Hijack it somewhere to rewrite it to 2 in one place. Yeah, I mean, it's probably just a sign that I need to modify all those functions, but Gen LE32. Really? I just copied that. Why don't you think? Oh, we got an error in libtcc at line 57. Oh, implicit declaration of function. Interesting, interesting. Do we like... I'm not sure. libtcc 57. Wait, what? We have to do this again in here? Interesting, interesting. Huh. Implicit declaration of function. Oh. Static declaration of G follows non-static declaration. TCC ASM. What's that all about? No. Why are they allowed to do it in this one? But I'm not allowed to do it. Hmm. Hmm. I don't get it. Hmm. TCC ASM 564. Yeah, is it like a header include order thing? Hmm. Maybe it's this. No. I'm guessing it's because we're using the function before it's defined. Static declaration of G. TCC asm.c 601. Okay. No, that's not declaring it. What do you mean? I'm starting to think we should have just like... Well, that's not right. So what is this going to do instead? Oh, they forward declare them here. Oh. Wait, do they do that in this one? No. Why don't they have to do it? I have a feeling a lot of things are wrong with my setup right now, but that's okay. Let's do this. Why are they doing that? Right after number of registers? Okay. Some warnings. Oh, everything's broken. Nice. Thank you for the raid. How was your stream? What were you up to? I'm in hell. Look at this. It didn't work on linking, so it's over. My life is over. Doing a classic rewrite in Rust, but it was already in Rust. Oh, that is a classic. It's curious that this is not a compiler error. This is it's a linker error. But I actually think we just gotta copy paste more functions and then we'll be good. We need load and the gfunc ones and then these ones. We just need all the ones. We gotta stub all the things. God, this is gonna be so incorrect. Like, what are the odds that we can even get hello world? Non-zero. That's what we like to see. Non-zero. What if you made a translation layer from another language's VM to SVM? Maybe the the problem is most languages have more instructions, and by a significant number. The approach I've been exploring the last hour: compile to WASM, recompile WASM to Synacor ASM. This part looks completely unfun. Yeah, because WASM has like 10 billion instructions and Synacor has 22. I had a Christmas party today and I have so many desserts in the fridge. Dang, couldn't be me. There is what Tired Beaver was saying, which is you could go to a language with less instructions. For example, brainfuck. You can compile to that and then translate that to Synacor. The problem with brainfuck in particular is that like you're gonna have a kind of an insane explosion of instructions. Like you won't be able to. The only thing you're gonna use your add instruction for is add one, and everywhere you need to go to a different number, it's gonna be like, and then we add one, and then we add one, and then we add one. It's not really a well-structured assembly that you'd want to generate machine code for. Yeah, the math stuff is weird. But I mean, it's not so much that I want like correct, idiomatic C to get compiled to Synacor. I more just want to be able to use C syntax to like program Synacor. So if it's a little bit busted and like non-semantic, that's fine. Like, I think implicitly all of my numbers are gonna live in modulo 15-bit land. Oh, thank you for the raid, Grumpy Game Dev. How was your stream? What were you up to? I don't think do I follow you? Let me see. I do not. I will follow you. I assume you were doing some game dev things. We came here to watch you write a compiler so we could feel something. My stream was, I was playing Dwarf Fortress. Is that what DF is? We don't feel anything? Yeah. I don't either. It didn't work. We're not feeling things except suffering and pain. Which I guess is something. My niece bought me a t-shirt for Christmas that had the word grumpy on it. You're taking a break because you want to sleep. All right, fair enough. I suppose if you're a quitter, you could sleep. Good morning, good morning. I don't know what we're doing right now. Like, I'm copy pasting code in hopes that it will eventually do something, but like the odds are low at this point. We're gonna take the signature of this function, we're gonna plop it there, and then who knows, maybe that'll do something. We also need store. This is how you make a compiler, right? It's just a bunch of empty functions. Pretty sure. And then you get a bunch of linker errors. Gen VLA SP restore. Mm-hmm. Totally. I feel like we would have been better off modifying one of the existing architectures than trying to add a new one. Technically, I have to work today. Oh no. Oh no. That is no good. Okay. Let's get gfunk call. And this one. And this one. And the prologue will probably actually be an empty function. Nice. That's a win. Epilogue. Maybe it won't be. Who knows? I don't know. Okay, I think we have all the G-Funk ones. Come on. Come on, just build. Oh. All right. We need a gen OPF. Gen OPF. Floating point things. This is another one where maybe we just say, like, oh, you did a floating point thing? I deleted from your code. What are you working on today? I'm trying to make a compiler. Or more importantly, I'm trying to, not more importantly, more accurately, I'm trying to make a new target architecture for an existing compiler so that it can run on my fake computer. I want to be able to write C code for a computer that doesn't exist. Because wouldn't that be neat? It's kind of bright in here. Oh, there we go. Dang it. Koovie man. Everyone's rating. Where are you all coming from? What about a stack language like Forth? Yeah, but then I just have to, like, if I have to learn a new language anyways, I might as well just write an assembly. Thanks for saving Raider's eyes. Yeah, no problem. Koovie, can you make cast compile to Synacor? Or can you compile the cast interpreter to Synacor so we can run cast in the VM? That could be good. I don't know what I'm doing. I'm trying to use TinyCC, but like, I need a gen VLA SP restore. You're not ready for it? Yeah. Me neither. I'm not really, like, there's no real point for me to do this, but here we are. I needed some gsim one too. Output a symbol and patch all calls to it. Oh, okay. We will probably want that one. Maybe. Undefined reference to gjump adder. Genfill nops. All right. Genfill nops. Oh yeah. That looks like a fun one. Assembly to Synacor bytecode compiler would be a neat intermediate step. Yeah. I think I will. I might consider having this output assembly as well as gjump as well as bytecode, depending on how I'm feeling. What did I do? What? Oh. Conflicting types for gjump adder. Really? Why does this one return a... Well, whatever. Mine can void. Oh, is it because the... Because I'm not actually returning an int? Yeah. That could be. No? Now what? Have int want void int. Okay. Sure. There we go. Oh boy. G go to. Have fun feeling things. We'll try. ASM parse. So does it really have all these? Oh, that's in the ASM file. Okay, i386 asm.c. i386 specific functions for TCC assembler. So what does this do? This just takes an unsigned int type. Let's ask ChatGPT. What's up with the file? Do I need to port that as well? Short answer, no. Long answer, absolutely not. Unless you want pain for no benefit. Okay. I mean, I like that answer. You're telling me what I want to hear. Inline assembly parser. Oh. Okay. Yeah, we don't need that. We don't need to be able to do inline assembly. You are correct. Do not port this file. Do not define. Do not pass go. Okay. You must not, under any circumstances. Is this in here? Oh, this is defined in here. Yeah, we don't want that. All right. Okay, okay, okay. What the heck is this guy? Hello. Parse an initializer for type T if has init is non-zero. Blah, 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 blah. If it's 2, a special thing happens. How cool. What are we compiling? C code. Everyone's favorite. Config TCCB check. I don't know. Is there a way we can get rid of this thing altogether? Probably not. Why is this not found? Oh, oh, okay, okay, okay. We need this one. Yeah, look, they've got one. Subtract from the stock pointer. Maybe I should be copying these functions. Nah, functions never helped anybody. What is this shit? Convert from one floating point type to another. All right, that will do nothing. That's illegal. I think anything with floating points, we just make it crash. Just make the compiler crash with an error that's like, you can't do that. Implement it in the application space. Like, implement your own floats if you need it. See the tweet. Points were never meant to float. All right. Gjump conditional. Gjump append. Don't know what that does. Not commented. Good. Love it. Love to see it. Come on. Come on. Oh, so close. Yeah, we just got some casting problems, right? I can live with that. Again, more errors, unsupported features. Holy shit. Did it build? I think we have a compiler. Sick. Look at my compiler. I know you're pretty impressed right now. It did it make anything? No, that was already there. Yeah. It didn't make anything. Okay. Yeah, it really wants these CRT things that I don't happen to have on hand. Yeah. Yeah. All right, ChatGPT, save me. Here, let's just give it this whole situation. All right, I've gotten to here. What's the plan? It only works on CRT monitors. Yeah. You've reached the TCC thinks it's a hosted system wall. This is expected. You're not doing anything wrong. CLib startup functions. Yeah, what is CRT.o? What is this? What is this guy? This is the core OS runtime objects. Thanks, Oracle. Required to enable basic C programs to start and run. Why? For why? I don't want that. Can I get rid of it? Is this because I'm trying to write an elf? Is it crashing when it's trying to make the elf? Perhaps. TinyCC assumes a C runtime, a linker, startup objects, libc. This is not about code gen. This is driver link phase behavior. Then it segfaults because after failing to link, it still walks data structures that assume those objects exist. You're compiling fine, then dying in the wrong phase. Wow, dying is a strong word. Stop TinyCC from trying to link. Compile only mode. Interesting. If I emit just an object, what does that give me? What is inside of an object file? I've never looked inside the object file. Can I just say like what.o? No. Oh, -c. Okay. We skip the startup thing if we just -c it. Now we just get our famous segfaults. It segfaulted in main. In the main function. I see. It's all starting to make sense. Yes, I wouldn't want it to be any more specific. I like a good mystery. Aha. Option B, robust. Force freestanding mode. Wait, are those real options? No standard lib. Oh, there is a no standard lib option. Sure, we can do that. I'm okay with doing this. How's the progress progressing? Things are happening. Would you believe it? Where do I do this? Here? This one. No, yeah, look, we made it segfault. I bet you're wondering where it segfaults. Don't worry. I can tell you. It's in the TCC compile function, which is in main. To be more specific. Yeah, somewhere somewhere it's not doing so good. Wait, where is TCC compile? Huh? That's not even a thing that's in here. Oh, it's inside of TCC add file. Is it because we're... I'll be honest, I have no idea. I don't know what's happening. I suppose we could step through. Go. What? How did it? Huh? Something is wacky. Oh. Oh, wait, I didn't rebuild after. Oh, okay. Yeah, let's get rid of that garbage actually. Okay. No, whoops. Nope. This one. No standard lib. Arg. What was the other one? No. No something. No standard include. Mm-hmm. I don't understand why I can't debug this thing at all. It's being built with -G, correct? What's that do? How will that help me? Source code context, stack variables. Meh. Like something is, it's not a configuration issue. Something is like wrong here. We don't have symbols. Why don't we have symbols? There's an issue with my make file. What target is it? Don't know. Why would I know? If equals config debug. How do I get that? Is that an environment variable? No. Oh, yes. Not true. Okay, there we go. GDB. Run. Look at that. Symbols. Yay. Yay. We do still have O2 for some reason, but much better. Okay, we blew up in the preprocessor. TC CPP. TC CPP. One line. 3716. Oh. Yeah, these other ones do define this thing, and I don't. I could see why that would be an issue. So picky. I don't know. I have no idea what this is supposed to be for, but ugh. Okay. No standard def. Is it because I took off the no standard include? Internal compiler error. VStack leak. Let's go. Hell yeah. What does that mean? Nice emote. Wow. Hey, I'll take a runtime error over a segfault any day. Any day of the week. VStack leak. Here it is. When we check the VStack, if the top is not equal to the VStack -1, then we've got a problem. All right. And this is used in what, 10 million places? Nah. All right, this might be where I stop for the night. I'm getting tired. But I still think, I don't know. I think this will be possible. Will it work well? Will it be bug free? Almost 100% no. But will it maybe be able to do some simple things? I think we can get it there. Will it take a year? Maybe. That is the one fear. I don't really want to spend a year on it. So if we can, maybe we time box it to, I don't know, the rest of the year. If I can get it done before 2026. Can we write a Synacor VM on this once you're done? Absolutely. Absolutely. Although somebody's apparently already done that. I don't even know how that would work. Because You would have to use up some of the memory of the VM for the VM. Like it doesn't have an escape hatch to get more memory. So you won't be 100% compliant. You're going to be... You're going to be cheating a little bit. But I don't think the core game uses the whole VM anyways. I think there is a bit of room in there. Because it's what, 50 kilobytes? How much room does that leave you with? I don't know. Sure, you can do it by the end of the year, just vibe code it and I already feel gross enough asking ChatGPT for help explaining TCC. Like, I don't even know if it's telling me the right things or if it's just leading me on a wild goose chase. That's the problem. But I think I'm starting to understand how this TCC guy works a little bit, a tiny bit, maybe like 1 or 2%. So maybe we'll get there. But yeah, I think I'm gonna go for the night. This has been interesting. Oh, Misaka's live. Classic. Misaka always watching other streams while streaming. That's next level. Twitch power user.
It's kind of confusion. Yeah, it's often very confusion, but then again, I'm a very confusing individual, I suppose.
Well, there's a lot of people here. Okay, goodbye, people. Have fun with the Misaka. Good night.